Asphalt mixes are produced in modern, computer-controlled plant facilities by combining different sizes of rock and sand, referred to as aggregate, and liquid asphalt cement, typically referred to in the industry as the binder. Based on the requirements of the intended end use and the job mix formula established in the design process. As a general rule of thumb, the larger the size of aggregate in the mix, the greater the load-bearing capability of the pavement. The contrast would be between a tennis court, for instance, and an interstate highway. Different types of liquid asphalt cement binder, some with performance-enhancing additives, are also used for different types of mixes. And this is why you'll find different stockpiles of aggregate materials and multiple liquid asphalt tanks at a modern plant facility. The production process itself is all computer controlled. Different sized aggregates are fed into individual hoppers, referred to as cold feed bins, and by using variable speed belt conveyors at the bottom of the hoppers, the aggregates can be extracted and ratioed from the cold feed bins into the plant based on the job mix formula and the desired production rate. A screen is typically positioned between the cold feed bins and the drying drum to keep any oversized material from accidentally getting into the mix. And the final conveyor feeding the material into the drying drum will have a belt scale in it, which measures the combined flow of the material as it passes over the belt, so that liquid asphalt cement can be properly proportioned into the mix later in the process. Since asphalt cement is a petroleum-derived product, aggregates must be dried and heated for the asphalt cement to successfully bond to the aggregate particles to produce the final asphaltic mixture or asphaltic concrete. The most cost-effective way to do this is with a rotary rock dryer with a burner embedded inside of it. As material enters the rotary drying drum, it progresses toward the burner, lifting and tumbling in the hot gas stream, drying and heating to the final mix temperature. This trip usually takes 3 to 5 minutes depending on the size and type of plant facility. As water turns to steam, the gas velocity inside the dryer increases substantially. This gas velocity can approach 50 to 60 miles per hour depending on the production rate and the moisture level. If you've ever stood on a beach in a storm, you know how this amount of wind can carry sand right off the beach and into the air. You can therefore imagine the carry-out potential as the sand and the fine aggregate are tumbled in a hot gas stream inside a dryer. This is important to us with our plant facilities because as you dry and heat material in the dryer, fine sand and dust particles are carried out with the steam and the expanded air. These particles must be collected and returned because they're important to the mix formula. The dust control equipment on the plant does this. The first square box in the duct is called a knockout box. Small sand particles are collected in this box and returned right back into the drying drum. The second and larger box, which has the exhaust fan attached to it, collects the finer dust. This box is filled with hundreds of bags on cages, much like a vacuum cleaner. Collected dust is then cleaned off the filters using compressed air or reversing the process gas flow, depending on the type of collector. And when it falls down into the hopper, a screw conveyor returns the dust to the process. Learning how to successfully operate a rotary dryer and the burner for controlling mix temperatures and the dust collector for fines return is a key skill set for a plant operator. Since asphalt pavements can be produced using reclaimed asphalt pavement, or RAP, plants are also equipped with RAP bins that allow proportioning of reclaimed pavement into the mixes. RAP is introduced into the drying drum after the virgin aggregates are dried and heated. A scalping screen to keep out oversized material and a belt scale is also used in these conveyors to measure the flow of the wrap into the plant, just like the virgin material. In the drying drum, what is actually occurring is the virgin aggregate is being superheated so that it in turn can dry and heat the reclaimed asphalt pavement particles. While virgin aggregate and wrap is being dried and heated, liquid asphalt cement is being drawn out and measured into the process. As we discussed earlier, there are typically different types of asphalt cement depending on the type of mix being produced. The asphalt cement is metered against the flow rate of the aggregate and the reclaimed pavement moving into the drying drum. The computer controls adjust the amount of new binder for both the virgin aggregate and the recycled aggregates that already have usable binder in them. Some plant facilities have a separate mixing device, like the mixing drum you see here, where the new liquid asphalt cement is added to the virgin aggregate and wrap as the last step in the mixing process. These outside mixers are added for a variety of reasons, but plants are also designed so that this entire process is accomplished in one piece of equipment. The completed mix now is transferred to the storage silos for dispensing into trucks. Most urban plants have several silos, so different mixes can be stored for multiple jobs. And the silos are often heated and insulated so the mixes can be stored for extended periods of time. Computerized loading controls the accuracy of the loading and ticketing process, and the mix is sent to the job.